Hey guys, so today we are going to add another piece to the puzzle. We are not going to actually learn anything new today. We're going to take a whole bunch of things that we already know how to do and put them together into one big problem. But the main idea is that we're going to be solving quadratic equations again. So in this example, you're going to notice, first of all, that I have a quadratic equation. But I'm hoping that you've noticed that it's not quite set up the way that we need it to be. We need it to be equal to 0, which means that that negative 80 needs to go over there to the other side. And the way we're going to do that is by adding a plus 80 to both sides. So that's going to give me the 0 that I need over there on the right-hand side. And be careful to make sure that you write the 3 terms on the left-hand side in the correct order, that you're going to do b to the second plus 20b plus 80. So the first step was that it's kind of an ugly 8. First step was that we just needed to get it in the correct format so that now we can solve it using the quadratic formula. And first thing, of course, is that we need to actually write down the quadratic formula. So that's going to be x equals the opposite, or negative b, plus or minus the square root of b squared. Eek, my handwriting is not doing great today. B squared minus 4ac, and all of that is over 2 times a. So the first thing we're going to do is do what you've done a number of times now, where we're just going to substitute in all those values for a, b, and c. I'm going to ignore this x equals, even though I know it's technically there. Okay, so I know it's there. I'm just not really going to use it right now. So negative b, because my b is a positive 20, that means that I'm going to substitute in a negative 20. Plus or minus is just part of the formula. Square root is part of the formula. B squared, again, b is 20, so I'm going to substitute in a 20 squared instead of a b squared. And then minus 4, which is just part of the formula, times a in this case is equal to that 1 that's in front of that b squared. So 4 times 1 times c, in this case c is 80. And all of that is over 2 times a, which in this case is 2 times 1. So I've substituted everything in correctly. And as you're going to recall from previous practice problems with quadratic formula, we need to next turn our attention to everything that is underneath the radical, everything that's underneath the square root. So that's where I'm going to start. So I'm going to start by bringing down my square root, and I'm just going to focus on that part of the problem for now. So 20 to the second power is 20 times 20, which is 400. And then 4 times 1 times 80 is 320. And I know that there's subtraction because the formula is minus 4ac. So 400 minus 320 means that now I need to determine the square root of 80. In every quadratic equation or quadratic formula, problem we've done up to this point, what ends up underneath the radical sign has always been a perfect square. And this time we don't have a perfect square. So even though it's close to a perfect square, because 9 times 9 is 81, it's not a perfect square. So this is going to be a little bit of a change for you guys. Now we've got to do something just a little bit different. And that's why we took a break from quadratic formula this week, to learn how to simplify radicals, because that's what we're going to do. We're going to look at this radical 80, and we're going to factor out of it the biggest perfect square that we can find. So I always like to write myself a list of perfect squares out to the side, because it just makes it a little bit easier for me. Yes. So then I've got all my perfect squares here. And I went all the way up to 9, because obviously I don't need to go any higher. And a lot of people are probably going to say that 4 is the largest thing you can factor out of 80. Even though that's not the largest thing, I'm going to go ahead and do it that way just because my teaching experience, again, teaches me that that's what most people are going to say. So most people are going to say that you can factor it into 4 times 20, which you can. You're going to take the square root of 4, which of course is going to be 2. So that means that now you have a 2 radical 20. But then you're going to notice, snap, I can factor another 4 out of that 20, right? Because 20 is also 4 times 5. So if I take the square root of 4 again, which is 2, and I multiply 2 times 2, that's going to get me 4 radical 5 for the simplified version of the square root of 80. And maybe you've got better number sense than I did when I was your age. I'm going to erase this. And maybe you actually realized that 16 is actually the biggest square or perfect square that you can get out of there. So then in that case, you would know that it was 16 times 5. And the square root of 16 is 4. So you would end up with a 4 radical 5 as the simplified version. Either way, you should end up with 4 radical 5 as that simplified version. So we're not just going to use our calculators to figure out like about how much the square root of 80 is. We're going to actually simplify those radicals in order to get a simplified version of that square root. So then, now that we finally did, so we dealt with all this stuff here underneath the radical. So now we've got to bring down the other parts of the equation that we've been ignoring for a little bit. So we're going to bring down that negative 20. So it'll be negative 20 plus or minus the square root of 4 radical 5. And then, of course, 2 times 1 is just going to be 2. So all of that is going to be over 2. So I dealt with my square root first by simplifying it. Then I went back and I picked up the rest of the formula because we've been ignoring it up to this point because we've been busy simplifying that radical. Now, what you would normally do is split it off into 2 problems because you would do like negative 20 plus 4, then negative 20 minus 4 radical 5. Now, this, because it's got that square root thrown in there, though, we can't really do that. But what we can do is we can simplify this expression that we have here because I can look and see that I can divide negative 20 by 2 really easily, and I can also divide 4 by 2 really easily. So I can actually do a simplified version of this expression. So I'm going to go to the negative 2 divided by, or negative 20, divided by 2 first, which is going to be a negative 10 plus or minus. And then the 4 divided by 2 is obviously going to be 2. And then the radical 5 is just there chilling out. You kind of want to think of the radical 5, even though it's not, okay, I don't want you to think that it is, but kind of like if you had a 2x instead of a 2 radical 5, like let's say this radical 5 were a variable instead, like 2x, it's kind of a unit, it's kind of all the same thing. So you don't need to do the radical 5 divided by 2. You just need to do the 4 divided by 2. So this would actually be your official final answer, negative 10 plus or minus 2 radical 5. You don't actually have to worry about it having 2 separate answers. Right now. Okay, so now for example number 2, I want you to pause the video, take a second, and think about what you need to do to get this in the correct format so that you can even solve it using the quadratic formula in the first place. I am going to hope that you have done that. I'm going to assume you did, and so I'm going to go ahead and show you that you'll do this by adding 30 to both sides so that we can get this set equal to 0 like we need it to be. So now we've got the equation set equal to 0. Step 2, we obviously need to do our quadratic formula. So what I would like you to do is pause the video, try to take the coefficients and the constants, try to take your A, your B, your C, and substitute them into the formula and see if you do that correctly. I'm going to assume you paused the video, so I'm going to go ahead and work it. So opposite of B, okay, so the first thing that we did is we got it set equal to 0 by adding 30 to both sides. And so now, hopefully, I want you to take a minute, try to sub all the numbers in there, and restart the video whenever you're ready. But I'm going to go ahead and get started, assuming that you did that. So if negative B means the opposite of negative 24, opposite of negative 24 means I'm going to substitute in a positive 24. And then plus or minus is part of the formula. B squared means that it's going to be negative 24 squared minus 4 times A. In this case, A is 1 times C. In this case, C is 100. All over 2 times A. So in this case, again, that's going to be 2 times 1. So hopefully you got everything substituted in there correctly. So if you've been paying attention, hopefully you also know that the next thing you need to do is focus first and foremost on getting this radical as simplified as possible. So I want you to pause the video again, take a moment, try to get that done yourself. I am going to assume, however, that you've already done that. So I'm going to go ahead and take care of that. So negative 24 times negative 24, because we're doing 24 squared, should have given you a positive 576. And then 4 times 1 times 100 gives you minus, because remember there's a minus in there, 400. Excuse me. Then we need to do 576 minus 400, which means we have 176. And if I'm looking through all my perfect squares, first of all, if I try to take the square root of 176 using my calculator, I'm going to get a jacked up decimal, which means it's not a perfect square. So I'm going to have to take some extra time to figure out what perfect squares can I factor out of it. So I'm going to make myself a list of my perfect squares. And by doing a little process of a little work in here, I see that I can factor it into 16 times 11. So if I take the square root of that 16, which is going to be 4, the simplified version of this radical is 4 radical 11. So now I need to turn my attention back to the earlier parts of the problem. So I've got that positive 24 that I need to bring down. So it's 24 plus or minus 4 radical 11. And then 2 times 1, which is obviously 2. So all of that is going to be over 2. So again, like I did on the last problem, that radical is throwing things off a little bit. So all I can do is simplify this the best I can. So I see that I can pretty easily do 24 divided by 12. And that gives me 12. And then plus or minus, the 4 divided by 2 gives me 2. So my final version of my answer is 12 plus or minus 2 radical 11.